Now, obviously, one of the great things about being able to determine this distance, this is what 1AU is the distance between the Earth and the Sun, is that it provides us the first interstellar baseline to explore the universe. Actually, people try to find these angles that you can see right here. This is theta. They are called parallax angles. So the fact that they couldn't measure these angles meant that the stars that we see around us are really quite far away when compared to what 1AU is. And it took a long while until the first parallax angle was measured. It was measured by this guy over here, that's Bessel. And it also led to the definition of what a parsec is. So the definition is here. Now, 1 arcsecond is simply 1 over 3,600 degrees. And the reason why parallax angles are given in arcseconds, on one hand, is because it's quite an appropriate unit. The angles are really small. But on the other hand, is because if you measure it in arcseconds, because we're always doing it from Earth, so the baseline is 1AU, you get distances in parsec. And you'll see that in astronomy, parsec is a very natural unit to measure distances to stars. And when we move to sizes of galaxies, we'll probably be talking about kiloparsec, and distances between galaxies to megaparsec. The other thing that is important to note, which is also written here and explained in the lecture notes, is that this angle, the angle that you see here, theta, is not the full angle that corresponds to sort of measuring a relative position of a star relative to the background in the summer and in the winter, but it's actually half of it. The reason for it is because theta is a parallax angle corresponding to the Earth moving by 1AU and not 2AU. Right? So if you were to actually measure the full angle that's here, then you would actually be looking at a baseline that's 2AU. And that is okay, provided that you then divide. And you could be measuring some phi, which is the total angle. If you divide by 2, you get theta. And the reason why parallax angles exist is something that you can do very easily. So if you pause this video and put your finger in front of you, and if you close one eye and then close the other one relative to the screen, which hopefully is not in front of your face or too close, you will see that the position of the finger relative to the background screen changes. And this is what we're doing when we're looking at nearby stars. So relative to very distant stars, nearby stars will seem to shift by a little bit. And the typical angles actually are so small that some of the largest angles are something like 0.77 arcsecond. This is for the closest star, that's Proxima Centauri, which means that when you look at parallax angles from stars, even those nearby, they're really hard to measure. In your lecture notes, you also have a few examples of how you actually compute these parallax distances given the parallax angle, and also with the first example. So Bessel was the first to measure and publish a parallax angle, and he measured it actually not for Proxima Centauri, but for 61 Cygni, which is at a distance we know now of 3.18 parsec that you can see right here. So this implies that when we move from summer to winter, that's 6 months, 61 Cygni actually moves by 0.63 arcseconds from like the furthest position to the other extreme. And if we see that, it means that the parallax angle is half of it. Remember that the baseline needs to be 1AU. And in this case, the parallax angle is actually 0.31 arcseconds. It's incredibly small, even though this is a relatively nearby object. And to calculate parallax distances is very simple. All you need to do is 1 over the parallax angle, and you get the distance in parsec. I think one of the important things to note, and we'll come back to this when we talk about telescopes and how bad our eyes are as telescopes, is that our eyes can only resolve down to something like 60 arcseconds. And this means that we can only see parallax angles, even if we could memorize the position of things every 6 months, which would be quite hard. we can only see up to essentially 0.02 parsec. That's incredibly close. And this is the reason why without telescopes, there's just no way we could measure distances to stars.